All right. Good afternoon, everyone, and welcome to the webinar. So today we're going to be talking about data blending and the ways we can mix and enrich the data sets using combination of tools and combining basically data sources together. Going with the theme, today your DJs are going to be Rob Aldrich, he's a senior consultant at Yellowfin, and myself, Andrew Saganov, I'm a technical consultant at Yellowfin as well. So the agenda for today is the following. First, we're going to look into the data sources available for connecting in Yellowfin. So we have the default data sources and we have some additional third-party connectors. We're going to look into the mechanisms of doing data blending that's available to us, and then we'll deep dive into an example scenario, which Rob will walk us through, leaving finally at the end some time for questions. So keep in mind just a few record-keeping things. The webinar is recorded, and you will get a link for the recording a few days after the webinar. And feel free to submit any questions as we go along, and we'll answer them at the end. So most of you are already familiar with it, with the data sources available in Yellowfin. So every time you add a data source, you're presented with an option to add it through a database, a cube, a GIND service, or a static CSV file. But on top of it, we also have a variety of different connectors which offer transformation steps as well as data connectors into third parties, such as Twitter, GitHub, Instagram, Google Analytics, and so on. And we also support a few integrations with machine learning models, such as R integration and PMML and so on. And today, for the example, we're actually going to be connecting through a JSON connector to a web service. So in terms of the mechanisms for data blending, two main ways can be outlined. First one is the transformation, is done through transformation flows. And the second one is advanced subquery, which is done at the report level. So we'll look at these in detail, starting with transformation flows. So the transformation flows can be thought of as a data processing pipeline. Usually they are done either like in a data preparation step. And as you can see in the screenshot, we have a few data sources on the left, which is a comma delimited file. Then we perform some processing and we output it into an SQL database. So this is the same place you can add integrations to additional transformation steps to additional third parties. And as you can see in the screenshot on the right, there's a configuration menu for configuring it. Yeah, so through the merge connector, and we'll go into more detail later. The advanced subquery, on the other hand, is configured at the report level. So because it provides a more interactive interface, and you can see the whole view in a column type at the column level, it can actually gives you a bit more options that makes it much easier to do some data wrangling. And as you can see on the screenshot, there's the interface is very similar, and you can choose to append or you can do a union, which is a familiar SQL type syntax or rather terminology. So to summarize the both methods, you can see the transformation flows is more for preparing the data, and you can build views on the outcome of these transformation flows for them to create reports. And at the same place, you can set up third-party integrations to R or some other additional processing. And in advanced subquery, it's configured usually after the transformation flows, and you can add additional rows once you're already in the report. It's good for column level type manipulations. And both of these mechanisms, they actually expose a similar interface for you to configure it. Is to do the joining is through a SQL type terminology using joins. So you can do left joins, you can do inner joins, and so on. But the way they are used actually depends on the scenario. So you may find using them in different times and for different reasons at different stages in the cycle of your journey exploring the data. So for the example today, we're actually looking at the top 100 Billboard songs in the period from 1965 to 2015. We're going to be using a fairly simple data set in a PostgreSQL database, which we are aiming to enrich with some additional data about the songs accessible through a web service, which we're going to connect to using a JSON interface, using our JSON connector. So the data presented in the JSON connector is actually a joint project between a group of people. We found it on GitHub, and we're actually connecting it through a JSON interface. So if you have more questions, we have a link down the bottom. You can check it out later. And Rob, now over to you. Take us through things.
Thanks, Andrew. So as Andrew mentioned, we're using the Billboard Top 100 dataset. This is a common dataset you can find, and there's many sort of Kaggle or data science type use cases or competitions this has been used in. So it's very straightforward. It's essentially got the rank of the song title, artist, the year, and finally the lyrics itself. Commonly, this is usually analyzed for more statistical measures. So basically things, how they rank across time, etc., and very sort of basic calculations. There's usually not much analysis that goes into using NLP or text analysis. So what we did was essentially find a repository on GitHub. There's a project where people, a team of data scientists actually got together and used Python and some of the Python libraries in there to do NLP and text analysis on the lyrics. So we're going to enrich our top 100 CSV, this file you're looking at here, with that JSON file using our connector. So let me switch over to Yellowfin. I'll just show you how I did that. I'll just log in here. So the first dashboard is, I've attempted to just show you a quick visualization to explore the raw CSV file. So essentially I've got the charts here. I can scroll through the different years, as well as the artist and title. I've also done some very simple metrics on word counts for the top 10. So you can actually see it colored by chart position here. You can actually see the different words and how often they occur in the title itself. So for the latest decade, you can actually see some of the words that are used in the title, and I can sort of move through time and just have a look how they change. I've done a similar exercise to the lyrics as well. So it's essentially just counting the number of occurrences in the lyrics. So again, you can actually see how they change over time. So, I mean, this is great. There's a bit of analysis that can be done statistically on, how often words occur, but really you want to be able to enrich that data, to actually understand the meaning of the lyrics. So that's when we use the JSON connector to connect to that GitHub project and actually augment or mash up their sort of semantic analysis in NLP with the raw CSV. So the way we did that, we actually created a data source, a JSON data source. I'll just quickly show you how that's done. That's using our JSON connector, like Andrew mentioned, is on our marketplace. I'll just jump in and show you the settings quickly. So essentially it's this URL here. For the purposes of this webinar, I'm only sourcing 1 year of data. but equally you could actually get the whole data set. It's all available in there from that link. So please explore it. It's actually quite rich. So once I've created the data source, I've built a Yellowfin report over it. So what this lets me do is some of the data wrangling, as Andrew mentioned. I'll just quickly show you that report. And this, again, allows me to bring in other data sources using the advanced query method that Andrew mentioned.
And as Rob was saying, we're not actually going through much of the visualization part in the webinar. So we're going to more into the transformation tool steps, an example, but we're not going to focus too much time on the visualization. Is that right, Rob?
That's right, that's right. So I'll focus on the transformation flow and how we actually get that data prepared, ready to do that visualization. So this is the JSON data in a report. You can see some of the columns here, some metrics around, word count. There's also some readability analysis that's been done here. So it's also ranking the word by difficulty as well and scoring that particular lyric by number of difficult words. There's also sentiment analysis, so positive versus negative sentiment, and various other readability metrics, which I actually haven't explored. And you've also got the artist, title, and tags as well. So I've done a little bit of data wrangling on here, and I've just concatenated some of the tags that are available in the data set, just to show you what you can do at the report level. Now, once you've created that report, you can actually bring it into Yellowfin and mash it up with the CSV file using our data transformation. I'll show you how I did that. Okay, so again, very simple. There's three main data sources I've got. The first one is the CSV file, which I've actually loaded into a Postgres database. You can see the fields I've selected here. So I want the rank, song, artist, year, and source. I don't really care about the lyrics at this stage because I'm actually doing the NLP and text analysis in the JSON. That's already done for me, so I don't need to bring that in again. I'm doing some filtering here. So if you remember, I've only got 1 year of the enrich data from the JSON source for 2015. So I want to filter my source data based on that as well. The second data source is actually the Yellowfin report. So this is the report I built on the JSON data source. So you can see some of the columns here. And lastly, I've pulled in a CSV file that's essentially got the images for each of the songs or artists. So I'm going to use that in my visualization later on. So let me just quickly run this in preview mode so you can actually see some of the columns in the data here. So this we know about. This is our standard CSV file, Billboard Top 100. This is the JSON report that's got that NLP and text analytics on it. And this one here is my CSV that's got the image that I'm going to use to visualize. Now, I'm merging it all together in 2 steps. So the first one is basically merging the raw CSV with that JSON report. And finally, the second merge here is combining the image. So
Rob,
yes.
Sorry to interrupt you there, but I see. So you're only using the merge tool steps.
Yes.
Other transformation tool steps are there?
Yep. I mean, there's a lot you can do in the transformation flow. This is a really simple example to show you the concept, but there's a whole range of transforms that can be applied, and this is some of them here. So there's a lot around machine learning, around geocoding, also the ability to embed data science models through PFA and PMML. There's R scripts. So from a data enrichment point of view, there's a lot that can be done external to Yellowfin and actually combined and embedded in the data pipeline here using the transformation flows.
Oh, cool.
And you've also got your standard sort of ETL type functionality when you want to do aggregations, calculated fields, filtering, etc. Okay, so this is the final output that goes to my table here, and you can see the columns in there. So I'm actually going to use this as the source for my visualization and reporting. So let's have a look at that. Let me just publish this. Now, these transforms can be scheduled. They can be run ad hoc. So if the JSON data changes, or if you've got some new data in your CSVs or any of your data sources, you can run them again. But I'll just show you the output. So again, I've created a very simple dashboard here. And this one's got more about the lyrics, so the quality of the lyrics, the text analytics around there. So usually an untapped area of this data set. The first chart here is basically showing you chart position by tags. So you can see the higher charted titles here are in the red. So things like R&B, for instance, charted very high. You know, things like disco, not so high. Pretty surprising in 2015. Moving further on, this one actually shows you your sentiment analysis. So again, you've got chart position on your horizontal axis and positive versus negative sentiment. So this one here is actually quite a high positive sentiment in its lyrics. I actually don't know that song, but that's quite a positive one. This one here is fairly neutral. You can see, you know, there's a balance of negative and positive. And finally, a highly negative sentiment. There's no actual picture for this one. For some reason, Taylor Swift doesn't like to have a picture on the Billboard Top 100. That's been ranked as a very negative sentiment song. Moving on to the final chart here. Now this one's all about lyric complexity. There's a lot going on in here. On the horizontal axis, you've got your rank again. The vertical axis, the number of words in the song. Now it's actually colored by word difficulty. So all your difficult words from a readability perspective are actually colored in red. So you've got the ones up here, look like outliers. So this one here looks like a rap song, and it's got a lot of difficult words. Similarly, that one as well. So all these ones, complex lyrics. Now the actual size of the circle or bubble on here is indication of the repetition. So songs that repeat a lot have got, you know, choruses that are repeated a lot are actually appearing bigger on here. So this is a Maroon 5 one. Again, not too familiar with this, but there's a lot of repetition in there compared to something that's a little bit smaller here. Not so many repetitions. So that sort of gives you a good idea of what you can do by actually getting a simple data set and enriching it with content you can find, you know, publicly available. To take the lyrics column of that data set, that CSV, and actually, you know, creating value out of it, enriching it. Back to you, Andrew.
Thank you, Rob. Thank you. All right. Well, that brings us to the question time. So if we've thought of any questions, please type them into the question area. Let's see if we have any so far. All right. We got one from James. If data is retrieved from a non-SQL database, like JSON, how do the joins work? So I can take this one, Rob.
Yeah.
So the way Yellowfin actually performs these joins is it's actually just a SQL like familiar sort of interface for people to be able to configure the joins. So it doesn't necessarily mean that you have to connect to a relational data source. So it works through an abstraction layer where Yellowfin stores it in memory and performs this type of joins on the stored data. So it actually doesn't have to be, it can work on any source. And then we've got another question from Kate. How is the JSON data refreshed? Do you want to take this one, Rob?
Yep, sure. So the JSON data is actually not persisted or stored in Yellowfin. So every time I run that report as part of the transformation flow, it actually goes and generates a request back to the GitHub repository and actually retrieves that JSON document every time. So if the content changes in the source repository, it will be updated in real time.
Cool, thanks. And we've got another one from Eileen. Is a request basically for more information. So, yep, I can answer this one. So we have a comprehensive wiki page, wiki.yellowfin.com.au. So you can find a lot of guides and detailed instructions on how to set some of these things up that we talked about today under the data transformation section. And there's also, if you want a more targeted response of a particular issue by your setup, we have the community page, which is community.yellowfinbi.com. So feel free to go there and submit a question. All right, we'll wait a minute to see if there are any other questions.
So I can't see anything in there. Any additional questions there, Andrew? So do you want to talk about the handouts?
Yes, certainly. So we have a couple of handouts. We can find them in the GoToWebinar download section. So have a look. There's some stuff about the machine learning, and as well, yeah, there's another one as well on 10 reasons why. I think if you have other questions after the webinar, feel free to reach out to us, and we'll be happy to answer them. Do you want to go to the final slide? Thanks, Rob. So thank you very much for joining us. Hope you found it useful. This is our, feel free to follow us on Twitter or check out the website and submit any questions through any of the links, the resources that I mentioned before. Yeah, basically that's it. Hopefully you've learned something, and feel free to reach out to us. Have a good day.